Okay, this is 4.2, Student Notes, Evaluation of Sinusoidal Functions. So I've given you a function here, and it looks like I took this off. So I'm going to find the general solutions and then find the three positive values. So given this function right here, when f of x equals 4, I'm going to take 4, set it equal to my function, and I'm not using a calculator here. I can do all of this by hand. And I don't want you to be scared of this. I'm going to show you how easy this is going to be. You have all the information you need to solve this. So algebraically, what you can do is you can subtract 4. That gives you -1. Bring everything else down. Divide by the 2, so you have -1/2. Bring everything else down. Now, when you get the hang of this and you find that you can cut some of these steps out, go ahead and do so. Now I'm going to go ahead and bring my sine over cosine. When you do so, that becomes an arc cosine of -1/2. That's equal to pi over 12 and x minus 6. Okay, from this point, this should look familiar, and we can find our general solutions. You're going to find 2 because cosine has 2 general solutions. So I need to know where cosine is negative. So we're not going to draw a triangle here or here. So my first one, cosine is negative in my second quadrant. So this would be adjacent hypotenuse and √3. And this is going to be 60. So this angle right here is going to be 2 pi over 3. Well, 4 pi over 6 and reduces to 2 pi over 3. Remember, when you're doing a general solution, you always add 2 pi in. I'm going to go ahead and draw my second triangle in my third quadrant. Again, this is -1, and this is 2 and √3. Again, this is still 60. So when you count around, this is 8 pi over 6, which reduces to 4 pi over 3, plus 2 pi in. Those are my 2 general solutions. Okay, now this is what I left off. You need to add this to both sides. So I'm going to add pi over 6 or pi over 12, parentheses x minus 6. The first thing I would do is get rid of this fraction, the pi over 12. So I'm going to multiply both sides by 12 over pi. If you multiply this right side by 12 over pi, I get x over 6. And if I multiply all the way over here, then that simplifies to just 8. If I multiply this number by 12 over pi, I get 24 pi. Then all I need to do, I guess I didn't need my parentheses here, I just need to add 6. That gives me 14. I'm sorry, that's not a pi. This is an n. Then if I can't add 6 to this because this is an n, so I'm just going to bring this down and say 24n, and this is equal to x. This is my final answer. Okay, I'm going to do this again over here. Same process. I'm going to multiply first by the 12 over pi. If I multiply it by this first number, I get 16. If I multiply it times this number, I get 24n again. If I multiply it times this number, this and this cancel, and I get x minus 6. Now I just need to add 6 to everything. That gives me 22. I can't add it to this because it's an n, so I bring 24n down, and I get equals x. Okay, here's my 2 general solutions. Now I need to do the B part. So I guess we could label this. This is what we did before. This was our A, and this is our B. Okay, in order to get B, I'm just going to plug values in for N. In this case, before we plugged in like 0, 1, and 2, you can plug in any numbers as long as you get positive values. Can you plug in a -1? Can you plug in a 0? A -1 will not give me a positive value. I can plug in a 0 and I can get 14 and I can get 22. If I plug in a 1 here, I will get a 38, and those are my positive values. So that would be my second part. Okay, same process when f of x equals 3. So I'm going to say 3 equals 2 plus root 2 sine pi over 4 x minus 10. And I'm going to solve this algebraically. So what I would do, and if you can combine steps, go ahead. I'm going to subtract 2 from both sides. That gives me a 1 equals root 2 sine of pi over 4 x minus 10. Let's divide by root 2. Let's see, let's go ahead and move the sign over. Remember, when you bring it over, that becomes arc sine. Now at this point, you should get your general solutions. So I want to know where sine is going to be positive. It's positive in these two quadrants. Okay, so I'm coming up with two general solutions. One is going to be in the first, one is going to be in the second. So when I draw it in the first quadrant, this is opposite over hypotenuse. This looks like it's going to be a 45. So this is pi over 4. Go ahead and do your general solution. So this is going to be plus 2 pi n. I'm going to go ahead and set up my second one. That's going to be in the second quadrant. So 1, 2, 3. Let's see, opposite hypotenuse. This is still 45. So this is 3 pi over 4 plus 2 pi n. This is still a general solution. Okay, then bring down the right side of your equation to both of them. So this is pi over 4 x minus 10 and pi over 4 x minus 10. Make sure you bring that to both sides. Okay, now I'm going to solve both equations, and I'm going to multiply by 4 over pi to both of them. I'm going to set that up on both of them. That would be the first step in solving both of them. If I multiply by 4 over pi to this first step, looks like it cancels out to 1. Multiply by 4 over pi to this, that gives me an 8n. 4 over pi to this cancels out and gives me x minus 10. Add 10 to both sides of my equation. That gives me an 11 plus 8n, and that equals x. That's my first general solution. Multiply 4 over pi to this 3 pi over 4. That gives me 3. 4 over pi times 2 pi n gives me an 8n again. Times this right side gives me x minus 10. Add 10 to both sides. That gives me 13 plus 8n equals x. That's my second general solution. Here's your general solutions to find your b values. Okay, because my n is smaller than just my value here, I'm going to try to plug in some different numbers here. I know I can plug in 0 to get 11 and 13. But can I plug in anything smaller than that? Because this is smaller. If I plug in a -1, can I do that? If I plug in a -1, I will get values smaller, and that works. A -1 plugged into this, I don't get a negative value. I get a 3, and if I plug in a -1 here, I get a 3 and a 5, and then if I plug in a 0 here, I get 11. So I plugged in values of -1 and values of 0. Okay, bring your questions to class.